we have an amazing session coming up because this is something that when I was reading the blog post from Matthew and the team on this thing, it just blew my mind. And I know that all y'all are going to love it too because I saw all the comments poured in and I saw all the views that this blog was getting. I was like, I need to know more about this thing, which is Infer Sharp. And he's analyzed all this cool stuff. So I got to bring in my good friends, Matthew and Jason. How's it going, buddies?
Hello, everybody.
Hi.
I'm really excited about this thing and your presentation because not only was it an amazing blog, but really cool graphic cover image as well. So I just gotta say, not a lot of people put time and effort into picking and choosing their images that get tweeted out, but y'all did. But I'm just gonna let you take it away. You got half an hour. Go for it.
Thank you.
Okay, everybody, we'll get started. For anyone who wasn't aware, this is Slain Zombie No Repo Crashes with Infer Sharp. Before we get started, I do want to start with an introduction. I'm trying to make sure we have time for Q&A, so I'm trying to rush through this in about 20 minutes. So we're going to stick to the important parts. Let me introduce Matthew Jin. He's our applied scientist who works on Infer Sharp. My name is Jason Arshaver. I'm a PM for Azure Developer Experience. So jumping right in, I started this off by saying zombie bugs, and I wanted to define this with you guys. Zombie bugs are the kind of bugs that you think you fixed it, you mark the ticket as fixed, and then it gets brought back to life. Not all bugs are zombie bugs. These are the ones that tend to reactivate themselves. So when we look at bugs, some bugs like the structural bugs, issues in syntax, issues with typing, these are structural. Your compiler, your IDE will typically show you these before you even compile your project. These are easy to find, cheap to fix. In the middle is bugs that are bugs caused around the logic. So either you just have bad logic in your code, you have bad math, you have an off by one issue, typing issues and weak typing systems where you're not getting the type that you're expected because there's no contract enforcement. These are logical bugs. These are harder to fix than the structural. They're harder to find than the structural. But you can typically find the flaw in your logic that will produce these bugs just by looking at your code more deeply. But the category to the right, integration bugs, are typically some of the hardest ones to find because these are bugs that are typically required a multi-threaded situation to raise their heads. They need multiple components. They rely on implied contracts. These are the kind of bugs that you can take a shot at time and time again, feel you're fixing things, and still not identify the original root cause. So when we're talking about zombie bugs, there's 4 specific types I want to call out today. These are resource leaks, where you grab access to a resource like a network connection and you never let it go. Thread safety issues, where we have race conditions, where a program has 2 parts running in parallel trying to read or write the same data. At best, this can be a hang. At worst, this will be data corruption or unexpected behavior. Null dereference is when you basically attempt to execute code on null. This will commonly result in a crash, but there's a long history of the wrong folks using this as a launching point for much worse. Maybe the easiest to understand is the concept of taint analysis. A lot of developers found situations like SQL injection as a common usage of this. They're also talking about things like unsafe serialization, DLL injection. These types of bugs produce real security vulnerabilities. Here's just a snippet of the walls of vulnerabilities that comes from these classes of bugs. So as we look at this, we're not the first persons to say, hey, is there a tool that can solve this problem for us? We have a history of making these tools. If we look at tools that are integrated into the compiler, so these are tools that when you build your code, it will instrument your code to help you identify what it's doing, potential bugs. So this is cases like the Roslyn Analyzer or Synopsys Seeker. Another very common tool nowadays is a signature or a pattern-based tool. These are basically where you write some kind of query or pattern and you look for it at scale. So this is FXCop, CodeQL, things like that. And then there's a set of tools that are what we call proof-based. These are where you use formal logic to reason through how the code will execute to identify problems. In the earlier days, we had prefast and prefix that do this. Some of you folks might be using these tools today. we're going to bring to you guys Infer and Infer Sharp. So I want to be clear. We're here talking about Infer Sharp, but Infer Sharp is built on top of Infer, which is a tool developed by Facebook for their production code bases. So this means they need to run millions and millions and millions of lines of code. So they need high performance scans. They also, every time you report a false positive to one of your engineers, you're kind of eroding trust. So you need to emphasize reducing the false positives so that when you show a new alert, the devs will treat those with a high priority and resolve them. What we did is we built a layer on top of Infer Sharp, developed by our Microsoft data and AI folks, that adds support for C# and any CIL-based runtimes, which includes the .NET framework and .NET Core. And we added that to the Infer's existing support for C, C++, Java, and other common runtimes. Regardless of whether you're using Infer or Infer Sharp, you do get your bug results out in serif form for easy integration to other tools. We're not the only folks. I mentioned that Facebook developed Infer, but Infer is broadly used across the ecosystem. Spotify, AWS, Uber, Mozilla all use Infer in production at scale today. So if I'm talking about Infer, I find myself compelled to take a moment to talk about CodeQL, which is kind of the big player, the big elephant in the room in the static analysis space. And I want to mention how it relates to Infer Sharp. When we think about CodeQL takes your source and it turns it into a graph, and then it runs a query on it, which is basically just kind of a fancy grep. And I know some of the CodeQL people don't like me calling it a fancy grep, but they've never given me a strong indication that they can do more than that. Infer Sharp, on the other hand, reasons about your code. So what do I mean by reasons and why is this important? Let's look at this very simple example. Can foo return null? If you view this from a query point of view, you might just write a query that says, hey, is there a path of this method that returns null? And we see that there is a null at the end, and if you reach it, it will return null. So yes, foo can return null. That's what CodeQL would say. But if you reason about this code, you'd see that once you enter the infinite loop of printing hello world, you're never getting out. This code will never return null. So you would think, okay, great, I can just add another rule to cover this kind of scenario. But now at this point, you're just chasing your customer's complexity. Maybe it's not a while true, maybe it's a variable evaluation that needs to be considered that leads to an infinite loop. It could be any number of complicated scenarios that result here. So just writing a query takes a lot of maintenance, requires a lot of time, but if we can reason through, we can get a more accurate result. So to get to kind of sell this message, I want to show you why reasoning is more powerful than query by looking at a few examples. And to do this, I'm going to hand it over to Matthew.
Great. So thanks, Jason. One of the main issues that developers have today with static analysis tools is that they give them so many false positives. And what this comes from simpler kinds of static analyses, which make these aggressive assumptions to try to work. This is and as a result of that, you get these overly aggressive alerts. For example, this is a screenshot of LGTM taken on which is LGTM, by the way, is CodeQL's website, applied to the Infer Sharp repo. At the top here, we have a cast operation. CodeQL's query-based approach thinks, okay, casts can theoretically return null, and it also gets dereferenced later. Well, because you have this cast operation, it gets dereferenced. Oh, we have an issue. A reasoning-based approach looks deeper into the control flow to actually figure out that the program conditions are not such that the type mismatch occurs, and therefore this null dereference doesn't occur in practice. So this is why a reasoning-based approach is able to avoid some of these false positives. It has a much deeper understanding of the actual semantic behavior of the code, which avoids some of these warnings. And on the flip side, there are a whole host of warning types that a reasoning-based approach can detect, which a query-based approach cannot. So it's quite common in .NET to create your own iDisposable classes. So for example, take this class on the left, which we call take and dispose, which wraps a stream. The constructor takes ownership of this stream. Now on the right-hand side, suppose we have the hello world of resource leaks. We create this take and dispose instance and we forget about it. We don't do anything with it. Well, the surprising thing is that CodeQL won't even be able to find this issue for you. And the reason is that you have to be able to actually have a semantic interpretation of these user-generated classes, like its constructor, its dispose, in order to be able to report on them. To hammer this point in more, let's take a step back and have a similar class here. We'll call it take without dispose, which is very similar to the one you just saw, where actually we've commented out in the dispose method, we've actually commented out the disposal of the underlying stream. And then on the right-hand side, we have actually a seemingly correct piece of code where we've allocated a stream. We've allocated the user-generated class take without dispose, and we actually invoke its dispose method. Certainly this looks okay, especially if you write a naive query to just look for dispose. The semantic interpretations of the behavior of the constructor and the dispose that Infer does is able to actually figure out that the underlying stream is forgotten about, so it'll actually be able to find the leak here. Now, a question for the audience. Is there a leak in this piece of code or not? So right here, we have something you all might have done before, a helper method, which returns a collection of iDisposable resources where, and you have this helper method that instantiates the underlying resources for you, and it returns that collection for you.
So normally in these kind of cases, we would ask you if you feel this is a leak or not. We're not using Teams, I believe. At least I believe on your guys' sides, you don't see Teams. So ignore my little graphic here. Sorry, Matthew. Well, I guess I should just go right on to the next item then.
So yeah, so we have actually not a leak, but what we do have is a false positive from CodeQL. What's going on here is that the file stream is stored in the streams object, and it's actually and that streams object is still reachable by the end of this method context, and therefore the underlying streams are still reachable. So as far as this method is concerned, it's totally fine. What Infer is doing under the hood here, which a query-based approach can't, is what we call reachability analysis. It actually has a model of what is reachable in memory by the end of a method, and therefore what is not reachable, and which didn't get disposed, so that we can very precisely report on exactly what didn't get what is no longer reachable. This kind of reachability, semantic reachability analysis is way beyond the capabilities of a query-based approach. So this is another critical example of how we're able to avoid some issues, some false positives that you might see with simpler tooling. Finally, another great example of the kinds of issues that you can miss with a cross assembly security is cross assembly security vulnerabilities. So, for example, suppose we have a simple SQL injection we have here. We have, say, maybe a data library where you have a SQL command that runs a SQL text, and you have a front-end library which passes a user-controlled string to that SQL command. Well, one of the cool things about Infer is its analysis spans across all of the assemblies that are given to it. And so it's able to detect some of these critical security vulnerabilities to keep you safe, which a query-based tool like CodeQL cannot do. And so I've told you a lot of fantastic things about what a reasoning-based framework, why a reasoning-based framework is so much fundamentally more powerful than a query-based one. But there's still a lot of work we can do. So false positives in Infer Sharp today largely come from gaps in the representation of the program that we pass to the analysis. These gaps largely fall into two categories. Today, we translate about 90% of methods. The remaining 10% of gap is basically because we don't translate every single instruction in the C# bytecode to date. But that's a gap we can tractably make progress on, and we will continue to make progress on as we continue to develop Infer Sharp. Additionally, there are library methods which are only available to the analysis at the which are not available to the analysis actually. But we can continue to model these, add models of their behavior to continue to close this gap as well. So we can tractably make progress to reduce these false positives. We're continuing to invest in productivity. We are working on generating patches to complement the bugs we detect. And we're really looking in the next quarters to shift left even farther into the inner loop of development of the developer lifecycle. So one of the things I really want to call out that Jason mentioned earlier in the talk is we are lightning fast compared to some of the tooling you might see on the web today, like CodeQL. On the right hand, we have a graph, which is the number of seconds it would take to scan a Blazor hello world. Biometrics, it was 23 times as long. So this should give you a picture of how fast we are to date before we've even on the whole project analysis, before we've even built the experience for incremental analysis, which is only analyzing the file you're working on. So this is what what I'm saying is we're fast today, and we will shift. We're getting even faster so that we can shift into your inner development lifecycle.
You know, I should mention as we look at this chart, some folks might be thinking, hey, why use Hello World? Why not a better representative app? But the gap only gets bigger the more complex the application gets. And I didn't want to ruin any credibility by showing numbers that look crazy, but there really is a huge gap in the performance here of what Infer Sharp's able to offer. So to show a bit of how you guys can use this, I'd like to have Matthew walk you through some of the experience of using Infer Sharp inside Visual Studio.
Thanks, Jason. So I'll be walking you through the VS 2022 extension experience today. We have a VS Code extension. It's essentially the same. It adds to your tools window Infer Sharp analysis button, which you just run that. And you'll be prompted to provide your binaries. When you do this, the analysis will run, and your warnings and errors will show up, as you see there. And they'll be highlighted along with all of in the same sort of area as all of the other analyzer warnings and errors you might see. On the right hand, we also show information about the warning. And also, you can even find the analysis steps. So we really trace through all of the code locations relevant to your issue. For example, with a null pointer dereference, you can actually trace through your code, click through your code to figure out the full control flow from where the null pointer got assigned all the way to where the dereference occurred. And as I mentioned earlier, this is quite a fast analysis. You can make your fix, rerun the analysis in the IDE, and boom, you'll see the error disappear.
So another element of Infer Sharp that I wanted to share, and this is something that we've only newly made available, is what if you want to create your own custom taint rules? So maybe you have your own object model where you want to make sure that that all inputs that make it into your object model are sanitized for, let's say, to prevent something like SQL injection or URL encoding issues. So if this is your situation, you can easily modify the .infer config file and add your own taints. Now, for someone who might be familiar with some of the other rules, like systems like CodeQL, creating rules is complicated. But here, all you have to do is basically define in a simple document what are the sources that start the taint tracking. Then you go in and you tell it where do you not want where do you not want those sources to sync to. So this is an example for SQL injection. Going back a slide, where you have HTTP inputs getting passed directly as command text into SQL. You would then give that a name. This is a SQL injection risk. And then you are good to go. And you can combine your different sources and syncs however you need for your security profile, your custom object model. I want to talk a little bit about how we use InfraSharp here at Microsoft. So there's 3 examples I want to show. The first one, or 3 stories I want to tell. The first one, the one that kind of our first big internal pilot was with the SQL Server team, who was finding seeing a series of slow memory leaks causing process crashes in their management service, and they were having trouble trying to find where these leaks are in their code. They were aware of the Infer tool, and they asked, like, hey, do we have something like this for .NET? It turns out we were working on Infer Sharp, so we ran our tool, and we've identified a number of memory leaks that was able to help them address their find and address the issue. We gave a presentation just like this internal at Microsoft, and a dev from the Cloud PC team thought, I should run this on our own repos. And he did, and he found a number of new unknown null dereferences in their code that was affecting customers. And they have then since moved to adopt this as a part of their engineering process. Kind of shifting out of the typical .NET world, when we look at our Microsoft Dynamics products, so these are business process products. They help you run your business, set prices, manage inventory, do retail sales, things like that. And they have a domain-specific language called X++ that's built on top of the CIL. They were interested in identifying some null dereference issues, and so they ran InfraSharp against their X++ runtime, and in the process found a whole slew of unexpected resource leaks. The main point I want to cover here is that these are the bugs that we're finding with internally with InfraSharp are not a set of pie-in-the-sky net new bugs that we're not sure if they're like, yeah, they're bugs, but we're not sure they're actually affecting the end customer. Instead, we're having people use InfraSharp to find the issues that are affecting their customers and provably solve those for the customers. Just like Claudia, I also want you guys to give us a shot, take a test drive. I believe we'll be putting a list of these links right in the chat. So you guys can click on these right from the chat. We are an open source project. You can find us on GitHub. If you have any feedback, please go to GitHub, open an issue, reach out to us. If you have a more direct question, you can feel free to reach out to Matthew or myself. Our emails are in the upper right corner. If you want to add this to your development process, we have extensions for VS Code and Visual Studio 2022. We also have extensions for Windows Subsystem for Linux and for Bash. If you want to integrate this into your CI/CD process, we do have a GitHub action already set up for this, an ADO pipeline task set up for this, and a Docker file that just makes this easy to drop into a alternate CI/CD process. With that, I was going to ask if anyone had any questions. I did want to make 2 quick notes ahead of time. When I moved slides over, some of them did show Microsoft Confidential. I do want to be clear, every single thing that I showed you guys today is completely free and open to talk about, and there's nothing confidential here. As I said, we are open source and we work in the open source. And whoever logger123 is, you made me miss a prompt for Matthew because I was laughing about your comment thread. So thank you for that.
Perfect. Thank you guys so much. This is absolutely delightful. And yes, Logger123 says that blog post was raising the bar, which is fantastic. And he did have they did have a bunch of questions in there specifically around CodeQL, but I think you did answer a lot of them. But I kind of will remix Logger's question a little bit because you did some analysis. What if I am using CodeQL? Should I use both Infer Sharp and CodeQL? There are different advantages that each of them do, or is it pick and choose your own, one or the other type of situation?
What I don't want is someone to walk away from this talk and think, well, I got to throw CodeQL in the bin, time to jump on the Infer Sharp train. Infer Sharp is really good at a lot of this reasoning logic, which helps us find a set of really difficult bugs and a set of security bugs and help folks address these quickly at dev time. CodeQL also is able to do some of that, but because of the performance of it, it's typically done trailing the rest of your build. So you might be 2, 3, 5 days away from when you submit the PR by the time you get the response back. And if that PR already got approved, now you're opening a bug for that issue. CodeQL, though, is extremely important for companies who have compliance requirements or policy needs that they want to use the rules in CodeQL to validate those compliance needs. I would not recommend trying to attempt compliance needs with Infer Sharp. Not what we're built for.
There you go. That's good to know because that was Logger's last question is like, why would they use CodeQL? So there's a good reason for it. It's not just one or the other. You can use both simultaneously. Good question over here from YouTube from Rajesh is really loving the Infer Sharp stuff. I'll just say they said great, but I said absolutely delightful, best presentation that they've ever seen in their entire life. It says he does say wonderful session. That's great. So I'm just reading in real time. How do they get it? Is it installed with Visual Studio 17.4? Is it a NuGet package? What types of projects? I'm just adding a bunch of stuff. You're like, yeah, how do you actually get it?
We recommend if you're a Visual Studio user, go to aka.ms/InferSharp4 VS Code or InferSharp for VS 2022 and just install our extension. All the hard work is done for you then. If you want to add this for CI/CD, you can just drop our GitHub Action Radio pipeline task into your CI/CD. If you have an alternate system, it's usually very trivial to call out to a Docker file in a CI/CD process.
Yeah, and our main landing is the GitHub page you see there. One of the things I want to add on the usage space is one of our most common asks right now is, can you get this working natively on Windows with no WSL? The answer is we are working on that. That is on the top of our plates now, so we hope to follow up with you guys soon on that.
Yeah, let me double down on that, just because it sometimes feels a little bit awkward. .NET tends to have a lot of presence in the Windows community as opposed to the Linux community. And Infer Sharp is built on OCaml, which is Linux only currently. We do have plans and are working to make a native Windows version available. But currently, you'd have to go through like Windows Subsystem for Linux or through Docker to break into a Linux to run the analysis.
Gotcha. Okay, but like you said, the tooling and everything kind of helps you automatically. I know WSL is always on for me all the time. One quick one here from Ajesh as well. Infer Sharp, is it an alternative to FX Cop? Is it the same? Are they doing? They're different things. I think I know the answer to this one, but I'd love to hear it from the two of you.
I view FX Cop as doing something different than Infer Sharp, in that FX Cop, which is also kind of a pattern-based system, is usually more for code quality and code styling, along with a set of common security issues. Infer Sharp is very focused on addressing these more complicated bugs and these security issues. So I kind of view them as tangential products, not living in the same world or same family.
Gotcha. Anything else to add on that, Matthew?
No, that's exactly what I agree with.
Awesome. Very cool. Well, thank you guys so much. I really appreciate it. It's always fun learning about these amazing tools that can help us build even better, safer code. Absolutely delightful. Well, thank you for your great presentation. And of course, it'll be available right here on YouTube, on the .NET YouTube. If you haven't subscribed yet, jam that like button and subscribe button as well. Jason, Matthew, you two have an absolutely delightful night. I really appreciate it. Cheers.
Thanks, everybody.
Cheers.